I need to do is I need to have a right triangle because that's the only way we know how to solve it. Well, what I see some people doing is they draw a triangle that looks like that. Problem with that is I don't know if any of those are 90 degrees. In fact, none of those are 90-degree angles. However, if I change where I draw that and I draw it over here, I can be certain it's a 90-degree angle because I create a rectangle, which means all four angles will be 90 degrees. Well, if this angle is 90 degrees, then the one inside is also a 90-degree angle. And now I have a right triangle where n is the hypotenuse. Well, this base, since it's a rectangle, it's a parallelogram, so opposite sides are congruent. So this side right here would be 14. And I could do the same thing with the 9. I can carry that over here, and that would make this distance 9. Well, if this distance is 9, and this total distance is 16, well, 16 minus 9, that makes this just 7. Now I have a right triangle with legs 7, 14, and a hypotenuse n. So now I can use my n squared equals 7 squared plus 14 squared. I'm sure I got everything correct. I do. All right, so if I do 7 squared plus 14 squared, we're going to end up with 245. So we're going to have n squared equals 245. Now I'm going to take the square root of both sides to give me n equals the square root of 245. Well, 245 is a pretty big number not to have a perfect square that goes into it. Usually I don't leave them out there that big that don't have a perfect square that goes into it. So you're going to go through your whole list of things you could possibly do, and it turns out that 49 goes into it. So we'll have the square root of 49 times 5. 49 times 5 equals 245. Well, I can split that apart to square root of 49 times the square root of 5. So we're just going to end up with n equaling 7 square root of 5, which hopefully was one of those up there. It was D. The correct answer was D. The next one isn't quite as hard because I gave you the right triangle. Either you know the Pythagorean theorem or you don't. In this case, 34 is going to be our hypotenuse. So we'll have legs x squared plus 16 squared equals 34 squared. Well, 16 squared is 256. X squared plus, 256 equals, 1156? And if I subtract 256 from 1,156, I'm going to come up with 900. So we'll have x squared equaling 900. Take the square root of both sides. You come up with x equals the square root of 300, which just of 900, which just equals 30. I had 30 on the brain. So x would just equal 30. Questions on those two? All right, there. Questions on the homework? Yeah, Lan. Number 12. Let me get number 12 up. All right, number 12 is basically a rhombus because all four sides are all x's. And so one of the facts about a rhombus is that your diagonals bisect. That's why we have a 45 and 45. But that also means that these both are 45 as well. You can either use your rhombus rules about that, or you can use the fact that it's a isosceles triangle. So we have 45, 45, 45, 45, and that must make this 90. So in fact, we have a square, realistically, because all four angles are 90 degrees. But long story short is I have this right triangle right here. I'll highlight it in red. Where I have two legs, x and x, and I have a hypotenuse of 6 square root of 2. So that means leg 1, which is x, squared, plus leg 2, which is also x, squared, must equal 6 square root of 2 squared. Well, on my left-hand side, I have x squared plus x squared, which just equals 2x squareds. And that's going to equal, well, when you square this, you're basically doing 6 squared, which becomes 36. Square root of 2 squared becomes 2. So I have 36 times 2 on the other side. Well, 36 times 2 is 72. So right now I have 2x squared equals 72. Well, just like 2x, if I have 2x on something, I just divide by 2 to get x alone. I want to get that x squared alone. So that's where this came in, where I'm going to divide by 2. 2x squared divided by 2 is just x squared. Divide the other one by 2 as well, and that's going to equal 36. Now we're down to x squared equals 36. Take the square root of both sides, and we have x equals 6.
So the 6 right over 2 is the dashed line in the middle?
Is the hypotenuse, yeah. Oh, that was probably your only question, huh? Oh, okay. Nope, that is the length of the line. That's probably your only question, right? Yeah, it's not the angle. It's the best I can do to show that that is that length. Hamza.
For like 19 through 24, do we know the triangles are congruent by angle sides? Or at least like 19. No,
19 through 24.
So we have to know the triangle that we look first, right? To know that the kind of like the line with the 2 right angles surrounding it.
Yeah.
Yeah, that's it.
And a lot of them are angle side angle. Yeah.
Okay.
Yeah.
You can't just assume it. That's the bottom line.
Correct. We'll have more advanced ones today. Yeah. All of these you can prove are either similar triangles or, for effects, split it in half. Just because they're all isosceles triangles with the right angle down there, that we could prove it. But yeah, those are mostly just take it on faith that they're all equal. Today is going to be a little bit different. Yeah. Other questions? Other questions going once? Twice? Denise. Wait till I get to 3, huh? All right, 20. 20, we have isosceles triangle. So this might be a good one because then I can answer Hamza's question maybe a little more thoroughly. So Hamza's question was, how do I know I can divide it in half? In this case, since it's an isosceles triangle, we know that these 2 angles are congruent. Which means these 2 angles must also be congruent. Because once I show 2 angles are congruent, then the other 2 have to be congruent as well. And we also have a side here, so we can use angle side angle to actually prove those 2 are congruent triangles. And you can do that on all of them, Hamza. I think a lot of them are pretty much the same idea. Okay, but here's the thing. So we have this entire length is 12. So now that I know both these triangles are congruent, I can say that this little segment is congruent to that segment. So they both must be 6. They both must be 6. Now I don't care about this half, and I just care about one of the right triangles. Well, now I have a right triangle with a leg 6, a leg x, and a hypotenuse of 10. So I just have to do x squared plus 6 squared equals 10 squared. Is that good enough, or do you have a specific question? That's good? Awesome. All right, let's go into today's lesson. Today's lesson, you actually have 4 of these problems in your homework, so make sure you pay attention and you know what I'm doing. So we are given a rectangular prism. In other words, like a box. And I have to get the length from this bottom corner to this top corner. And the only skill I really have right now is right triangles. Well, this is a 3-dimensional figure. Right triangles are 2-dimensional figures. So what I'm going to do is I'm going to break this down into 2 2-dimensional triangles. And what I'm going to do is I'm going to draw a line. That's basically the shadow of A. That dashed line is the shadow of A. Now, I don't know that length, so I'm just going to call it B.
What do you mean by the shadow of
I'm just saying if A would cut straight down, it would be B.
Oh, okay.
We're just drawing this line. So from that corner to that corner, two-dimensionally, we're going to draw B. That's going to create two right triangles. I'm going to draw those two right triangles. Our first one, if you kind of look at, would be the best way to do this. I guess maybe highlight in green really quick. Our first two-dimensional triangle is going to be that triangle I'm covering right now. So you kind of see that base triangle that's just lying there? That's going to be the first triangle I'm going to pull out of it. So that would be a right triangle that looks like, kind of like this. I guess I should stick with the red line being B. That'd make this 4 and this 6. That is a two-dimensional right triangle because this would be a right angle right here. There's another right triangle in there too. There's another right triangle in there, and I'm going to highlight it in green again. It would consist of all of A. It would come down 3 and would be this triangle here. Can we all see that two-dimensional triangle? And it would be a right triangle as well. So I'm going to go ahead and draw that off to the side. Where that length would be A, this would be 3, and this would be that base B. It says I'm supposed to solve for A, correct? I need to find that length, A. Well, if I tried to solve for A on that top triangle, we're going to end up with A squared equals 3 squared plus B squared. But I don't know what B is. That means I have to use this triangle to solve for B. All right, so in this triangle down here, so we're going to go down to that bottom one, we're going to solve for B, because I do know both the legs. So we're going to say B squared equals 4 squared plus 6 squared. Well, if we work this out, we'll come up with B squared equals 16 plus 36. We'll come up with B squared equals the square root of 52. Now we could reduce that. We could actually, but I'm not actually solving for B. What is kind of a nice shortcut in this problem is taking that square root of 52 and saying, well, that equals, oh, not the square root of 52. I'm sorry, it should have just been 52. I went too far. I was thinking not to do that. Notice that it says B squared equals 52. So I can take that 52 and plug it in place of the B squared, which is going to give me A squared equals 3 squared plus 52. So I could have taken the square root of both sides and came up with B equals some number and plugged it in for that B, but then when I square it, it comes back out to 52. So why do that extra work? I'm also going to go ahead and replace that 3 squared with 9. So now we have A squared equals 61. If I take the square root of both sides, I come up with A equals the square root. Whoa, throw stuff. It's not that bad. All right, so if I take the square root of both sides, come up with A equals the square root of 61. There is no perfect square that goes into 61, so that is in fact our finished answer. Here's the problem with this problem. That's too many problems in one sentence. If this shows up on a test, the only way you can solve it is to know to draw this line. So that's why it's important that you know the strategy to solving this problem. There's no other way to troubleshoot your way through it. You have to start out by drawing that line. in order to get the other two triangles. I kind of equate this to, if you remember the problems that were like, it's completely different, but it's kind of along the same, that you just kind of have to have it memorized. I'll bring it back up for people that aren't. We had problems that look like this. We had a parallel line, this is 45 degrees. If you remember this one, you had to draw another parallel line in. And either you remembered how to do it, or you didn't. I know I put that in the final two. Either you knew how to do it, or you didn't. This is one of those two. Either you know to draw that line, or you don't. So what I'm getting at is make sure you study these problems. Make sure you know to put that line there when you have a problem like this. Otherwise, you can't. You get 0 points for it. Hamza.
So how do you know where to like connect like one point to the other? How do you know which point?
You always know because it's going to create two right triangles. So your first goal is to create a right triangle that has A in it. So that's why I said do it in its shadow. So the first thing I'm actually doing is I'm drawing this B. I'm actually looking at this first triangle first. I'm just trying to create a right triangle that has A in it. It's kind of like this one. I'm trying to create a right triangle that has N in it. And then I hope that will solve the rest of my problems. In this case, it does because that B turns out to work on this right triangle. So your first goal is to create a right triangle using that variable. So I only really cared about this triangle starting off, and it just so happened to create that other triangle that can help me solve it.
Yeah. So I understand how the right triangle is the 6 and the 4, and I understand why.
It says that AB equals 18. It says that AC equals 34. And it says that CD equals 16. It says, what is the length of BC? So I'm trying to find that length of BC. If I look at this right triangle, if I knew this length from D to B, I'd be able to solve it. A squared plus B squared equals that length. Unfortunately, that's a mystery length. That's a mystery length. Let's go ahead and call it maybe X. Because I don't know that length, but I need to find it. Well, we have a big right triangle that can help us find it. And that big triangle is triangle CDA. So I'm going to draw that underneath. I'm going to draw CDA. So CDA. I know it's a right triangle because they told us that. I also know the length from C to D is 16. I also know the length from C to A is 34. Which means I can find this full length. Well, if I find this full length, I'm going to be able to find X. Because this full length minus 18 is going to be my X value. So let's go ahead and solve for Y. Well, 16 and Y are our legs, so we'll have Y squared plus 16 squared equals 34 squared. 16 squared is 256, so we'll have Y squared plus 256 equals 34, I always forget, is 1156. Then we subtract 256 from both sides to give us Y squared equals 900. Take the square root of both sides, and you're going to come up with Y equals 30. Well, we can take that Y equals 30 and say, well, that's that entire length. So if that entire length is 30, what is the length of X? It's easy.
12.
That'll be 12. So I can replace that X with 12. Well, now we have that little triangle where I'm just trying to find the hypotenuse. I'm going to draw that little triangle off to the side. Where I have 16, this is my right angle, And this is 12. I already used X. I used Y. Let's go ahead and use Z. Well, that's a right triangle with legs 12 and 16. So my hypotenuse, which is Z, would be Z squared equals 12 squared plus 16 squared. That will give me Z squared equals 144 plus that 256, which we're going to have Z squared equals 400. Take the square root of both sides. We're going to have Z equals the square root of 400, which just equals 20. And that means BC, maybe I should have labeled this triangle that it up here. Let's label it C, B, D. So BC equals 20. Any questions on what I did there? So sometimes you just have to recognize which right triangles you can actually solve values for. And then hopefully that can help you solve for the value you are looking for. All right, questions for me? All right, then I want to go over something really quick on the homework. Some of these can be tougher because you have to use rules that you might not remember. For instance, I'm looking at the wrong homework. That's why. I was like, those are all pretty easy. Number 28. You have to use an angle bisector theorem of ratios. And I can help you with that when you get to it, if you have questions on it. 31, you have to understand medians and altitudes. And on number 37, you have to use similar triangles. There's one more that you need similar triangles on. It's slipping my mind, but I know you need similar triangles on 37 for a fact. So those you might need a little help. Ask questions or just quickly look at the answer guide to see what rule you're missing. And then try it without just copying down the answer, right? Just look, oh, that's what similar triangles are. That's how we use those ratios. All right, so don't use the answer guide just to copy stuff down, but you can definitely use it as kind of a guide to answer questions. Otherwise, the rest of the time is yours.